Today we want to start off with these two problems. Seems kind of a strange topic. We just finished talking about implicit differentiation, but it is Friday, and that means I do want to introduce the next big thing before we get to the next big thing. That way on Monday when we come in, I will have forgotten that this happened. I forgot that we were moving on to the next big thing, and we'll just be doing something else. But this will be planted in the back of your mind for when the next big thing does show up. This is called going after your subconscious, or Inception. They made a whole movie about a thing that we do on a regular basis. You just have to mention stuff to people, and then there you go. That's Inception. You'll start thinking about it. All right. So pause the video here, take a few minutes, and do these two problems, please. Welcome back. Now, the first thing we need to know is that we're calculating an average. We just need to add up all the total and then divide by how many things are there. That's all average is. It's like a density. How much is there divided by how much space it's taking up. So we're going to use our usual 4-point system, which is actually a 5-point system, 0 through 4 for A through F, and then we can calculate an average of these grades. So I've done that here. All we have to do is figure out how many grade points there were. So I'll have 12 A's, so 12 times 4, 14 B's, 14 times 3, 8 C's, 8 times 2, 3 D's, 3 times 1, and 1 F, 1 times 0. This is always referred to as a 4-point scale because it's a maximum of 4 points, but notice there are in fact 5 points because one of them is 0. This is a ridiculous system because there are 2 failing grades. Why do we bother with 2 failing grades? D and F are both covered by D here in college. If you get a D, you have to take the class over again. If you get an F, you have to take the class over again. Why have them both? But that's beside the point. This is how many grade points there are. Now we just need to divide by how much space they're taking up, because that's all density is. It's an average. How much is there divided by the amount of space it takes up. And I used a machine to do this because this is the kind of thing we ask machines to do. So we end up with a 2.868. Which is 2 33/38. We'll call it 2.87. Which lands us in the between C and B. If I had to round this up to a whole grade, we can go with B. We could sit there and debate about whether it's a C+ or a B-. That I think is probably an empathy test. If you're nice, you're going to want to go B-. Any questions? In the second problem, I drive from point P to point Q at 80 miles per hour, and apparently there's traffic coming back because then I turn around, I drive from point Q to point P at 60 miles per hour. My question is, what was my average speed on this trip? And the subtext of the question is, why was it not 70? Why are we not gonna fall for that?
It's not enough information. If we don't know what's the distance from P to Q.
That's a good point. What is the distance from P to Q? It doesn't matter what the distance is from P to Q because it's the same distance in both directions. So, but no, we don't care. We can, so the distance from point P to point Q is D for distance. What was our average speed while driving, and why was it not 70 miles per hour? Is it going to be more than 70? Or is it going to be less than 70? And why? That's what we want to think about here. Does it? Am I trying to be cruel and not give you enough information to solve the problem? Do I do that? Would I do that to you? Yeah, I totally would. Because the question might be, can you determine if you have enough information to solve the problem? That's an important consideration. Is there an answer? In math, we say, does an answer exist? We care about existence. Then we care, is this the only answer? We care about uniqueness. That might be one of the avenues that I took on this problem. Maybe I just didn't give you enough information.
A speed from what it looked like it's 70 divided by
Yeah, but we don't get to use 70 because I said it's not going to be 70.
it's 70 divided by b.
Now, if we take 70 and divide it by the distance, if the distance is like, then our average speed will depend on the distance. That's not how it works. Distance divided, what is our average speed? How are distance, rate, and time related? We know the distance is equal to rate times time. What I want to know about is an average rate. So I'll divide both sides by t. So rate is distance divided by time. Well, that makes sense. Distance divided by time. Miles per hour. Per is just a word for divided by. Miles divided by hours. We can also calculate time. We can take distance divided by rate. So, do we need to know the distance from point P to point Q? How could we figure that out? How could we examine this? Here's the important part of the question. I certainly implied in an attempt to be very rock-like that it didn't matter what distance the distance was from point P to point Q and from point Q to point P. So what should we do? Which, do you have a suggestion? Oh yeah, we could do algebra. We could set it to what? Why would we set it to 1? That would be really inconvenient. No, that's inconvenient too. There's an 8 and a 6. What would be more convenient? Oh, but they also have zeros. So 6 times 8, 48, put a 0 on, 480. Now, when it comes to calculating, I can divide and everything will be cool, right? Because look what we have to do. We have to take the distance and divide it by the time, or the distance and divide it by the rate. So I don't want to have fractions running around. No one likes that. So yeah, we're going to do a combination of those things. We could just stop. The last thing that we want to do is look at the problem and say, well, there's not enough information, and not do anything else. That's not okay. It's like, well, the distance wasn't given. Does that mean the distance doesn't matter? We can't just automatically dismiss that. And the worst thing that we could do is say, well, that seems reasonable, because that seems reasonable is never a reason for anything. That seems reasonable is a terrible way to do things, especially on something that we can examine more closely. So that's a great suggestion. We're worried that we're not given the distance. That should raise a question. Perhaps the distance doesn't matter. So we'll pick a distance. Actually, we can get away with a smaller one. We could get away with 240, but I'm going to use 480 anyway. So we might be like, oh, does distance matter? Let's find out. Let's try 480 miles, the distance from P to Q. So the instinct we should have is to test what's going on. If we're not sure if the distance matters, let's pick a distance, figure out the average speed, change the distance, and see if anything changes. That's how science works. We try stuff. So I'm going to pick 480 miles because it's a nice multiple of the 6 and the 8. Question? So I picked 480 because it's a nice multiple of 6 and 8. Because now that I have 480 miles, a distance, and I have 80 miles per hour and 60 miles per hour, some rates, what should we calculate? Time. That's the thing, the third piece that we don't have. So we can calculate the amount of time it took us to drive from P to Q. So time is distance divided by rate. The distance was 480 miles. And we'll divide by our rate. From P to Q, we were going 80 miles per hour. 48 divided by 8 is 6 hours. $80 is our speed from P to Q. I was doing 80 the whole time. I can accelerate instantly. Inertia be damned. I don't teach physics, so I'm not subject to the rules of physics. I do math problems. I'm subject to the rules of math. And math says, just do 80 the whole time. And when the police pull me over, I'm like, oh, dude, you're messing up my average. And they're like, oh, I don't care. You were going too fast. And then I show them my badge. I'm like, oh, math teacher doing a math problem. And like, move on. Move on. It's one of the benefits of being a math teacher. It's not because there's some kind of law. It's just that no one wants to talk to you. So the time from P to Q is 6 hours. And the time from Q to P is still 480 miles. But now we were only going 60 miles per hour. So how long does it take? 8 hours. So before we calculate our average speed while driving, why is it going to be less than 70 miles per hour? Why is our average speed going to be less than 70 miles per hour or more than 70 miles per hour? I'll phrase a similar question. Why was the average grade in the previous example not C? A, B, C, D, and E, or an F. C is in the middle. C is the average, right? Isn't the average grade C? Why was the average grade not C in the previous example? Those are the 5 grades. C is in the middle. There were more A and B, A's and B's than there were C's, D's, and F's. Right? There were more B's than C's, D's, and F's. That's going to pull up the average. So is our average speed on this, on both directions, for both directions, more than 70 or less than 70? It's going to be less. And why will it be less? We spent more time doing 60 miles per hour than we spent doing 80 miles per hour. So even though we drove the same distance, coming back, it took us more time. So our average speed, let's see, our total distance. Our total distance will be 960 miles. And we'll divide that by our total time. So 960 over 14. $68.57. So it was less than 70 because we spent more time doing 60. So that brought our average down. In the same way, the average grade and test was higher than C because there were more instances of grades higher than C. Any questions? I usually complain that averages are terrible. And one of the reasons I complain about averages being terrible is that we're not very good at them as humans. We see two numbers, we hear the word average, we automatically split the difference and go right in the middle, but that's not how it works. When we look at the average home price in the Bay Area, well, let's not do that. The average home price in, let's use the entire country to bring it down. One is going to be higher than the other, not because every single home here in the Bay Area is more expensive than every single home in, say, Arizona. I pick Arizona because I have a brother-in-law who lives in Arizona. And he has a house that's like 3 times the size of ours that costs, I think, literally a third of what ours was. So it's like a factor of 9. But anyway, he doesn't watch my videos, so it's okay that I'm disclosing. I'm not even complaining because the drawback is he lives in Arizona. One time I went to visit and it was 110 degrees and I was like melting. I was like, oh, Steve, this is ridiculous. How do you live like this? And he's like, oh, it's cooled off since last week. You should have been here last week. I'm like, oh, no, I should not have been here last week. I'm already complaining that it's 110. You said it was more last week? No. This is why I don't live in a desert. But anyway, that's beside the point. So there's certainly a house somewhere in Arizona that costs more than a bunch of houses here in the Bay Area. I'm getting close to the retirement. It's like, oh, am I going to retire to Arizona? Then I look at like the climate crisis. I'm like, oh, no, I'm not going to a desert. There's already water problems. At least it won't be underwater. There's that. But when you take the average, you have to look at all the values that there's only a few that are really expensive and most are going to be a lot less. And that's what's going on with our average speed. We're spending more time at the lower speed for the same distance. Just like in the test question, we were spending more grades on higher grades. That's pulling the average up from C. Any questions? Works okay with the C. You knew that the value, if you did your calculation, you got something less than 2, you know that something would have gone wrong. If you made this calculation, you made a typo somewhere, and you got a value that was less than 2, you would know that something is wrong. So if I made this calculation, I'm like, oh, 1.84, we should know instantly there's something wrong here. There's clearly something wrong because there's too many grades that are above a C for the average to be less than 2. That makes sense? This is why if I gave this problem on a test, this wouldn't be 0 out of 4. This would be -4 out of 4. It'd be like, oh, come on, man. Pay attention to what you're doing. Don't just listen to what the machines are doing. That's how the robot apocalypse happens. We just listen to the machines and let them do all the work. You know what I mean? Not about the robot apocalypse. But I used to refer to the robot apocalypse by saying Skynet, but does anybody know what Skynet is? It's funny. This class knows what Skynet is. My 8 o'clock class are like, oh, what's Skynet? I go, wait, what? It was very strange. It was very strange.
It's already being brainwashed.
It's already happening. They're only gonna watch like movies with positive robot role models. Meet the Robinson. Exactly. See, they're only watching the positive. The robots are like, oh, we can't have all this iRobot shit going down. We need something more positive. Wally. Yeah. Wally.
Wake up, people.
Anyway. I don't think that here's the thing. Here's my complaint about Wally. Not that I'm complaining about Wally. It's a wonderful little movie, but I don't think humanity can build a machine that would just last that long. I just don't think we have it in us anymore. Especially because it's set up in this dystopian world where it's like where like corporations have taken over. The corporations are not going to let you buy one machine that lasts for hundreds and thousands of years. Why would you do that? There's no way that Apple is going to sell me an iPhone 13 that I'm going to be able to use for 30 years. There's no way. If it's still working after 10 years, they're going to come after it. Not physically, but just remotely. And you're going to be like, oh, my phone bricked. And they'll be like, oh, wow, I guess it just got too old. You know how that goes. You know what I mean? That's true. He does harvest parts from other robots. So, which is, I mean, Wally is cute and all, but replace Wally with like a person, and he's like a necromancer. He's like, ah, look, I found some humans that have died. I could use a new leg. They aren't using it. Yeah, they're not using it. Anyway, what are we talking about?
If Wally goes from point P to point P.
If Wally goes from point P, see, when he's coming back from Q to P, clearly that means he found something interesting, and that's why he's going slower. And his average speed is lower because he's spending more time at the slower speed because he's carrying more weight. I don't think Wally has 70 miles per hour in him. Maybe when he's out in space and he has a little the fire extinguisher, then he could fly around. Anyway. All right. What are we talking about? Oh, yes. So, here's what we want to think about. What does this have to do with calculus? Maybe you're not even concerned with what this has to do with calculus, but apparently I am. So, calculus. The calculus actually shows up in distance is equal to rate times time. If you recall, one of the big questions in calculus that we introduced at the very beginning of the semester was, what is the area under a curve and above an interval on the x-axis? What is the area under a curve and above an interval? So what we're concerned with is area. And all we care about area, now that we have calculus, all we care about with area is equal to length times width. Every other area formula we have is just some niche area formula that we had to figure out because we didn't have calculus. And it only fits very few things, like the area of a triangle, 1/2 base times height, the area of a trapezoid. I don't say that one because no one remembers it. It's kind of funny. The area of a parallelogram, just base times height. That's just a tilted over rectangle, so that doesn't really count. The area of a circle, pi r squared. These are all just specialist area formulas that we use in those particular scenarios. But the only one that we really need is area is equal to length times width. Length times width is the only one that we need. because we're going to have the power of calculus. Then, once we learn how to use length times width, we start seeing every application of multiplication as an application of integration, which is our next big thing. So distance, the one that we just used, distance is equal to rate times time. Mass, this is one we used at in the first problem. Mass is equal to density times volume. This is just the usual version of density. Mass is equal to density times volume. Density is mass divided by volume. How much is there divided by how much space it takes up? How many grade points are there divided by how much space those grades take up? That's just the density. Lots of things with density. But this one's the most common. Here's what we want to do. We, of course, want to be able to calculate areas of things that are not just rectangles. So here's what calculus does. Stage one, what if length is variable? What if we don't have just one length? Stage two, the calculus one. What if length is continuously variable? This is where shit gets weird. What if length is continuously variable? If length is variable, we just drop it back from multiplication. All we have to do is drop back from multiplication to addition. If length is variable, we just use addition. That's what multiplication is for anyway. Multiplication is just addition when it's all the same thing. If all the stuff is the same, we just get to use multiplication. If our sum says 5 plus 5 plus 5, we get to use multiplication because all the stuff is the same. 3 times 5, 15. But if our terms are different, we don't get to use multiplication. If it says 3 plus 4 plus 5, I don't get to say 3 times anything because it's not all the same. Multiplication is just summarizing addition. So if our length, instead of being a constant 5, when we get to use multiplication, drops to, becomes variable, 3, then 4, then 5, then I have to use addition. I don't get to use my repeated addition, I have to use regular old addition. The problem arises if the length is continuously variable. Because now the question is, but where do we put the plus signs? If the length is continuously variable, now we're going to have to reframe how we think of addition. And this is why we need calculus. I don't know if this is why we need calculus, but this is one of the things that we use calculus for. We want to find a sum, but it's a continuous sum. There's nowhere to put plus signs in between stuff because there is no in between stuff. It's a continuum. So What's this have to do with our average speed? It could be that we have a constant speed. And so we get to use multiplication. It could be that we have different values. But in that case, we would just use addition. The continuously variable problem in that first one, we don't need a plus sign. We just have to multiply. In the second one, well, we could just multiply, or we could just add. We just drop to addition, just add. But in the third one, we got nowhere to put the plus signs. What? How's everybody okay? All right, so this was not about test question type of stuff. So don't look at this and say, wait a second, how am I supposed to answer this on a test? Stop worrying about the test. I just wanted to do inception to make you think of this continuously variable multiplication business. Area is equal to length times width. If our length is nice and constant, congratulations, we get to use multiplication. We're back in the 4th grade and everything is cool. Hopefully recess is coming up. In the second version, the length is changing. That's those geometry problems where you had to split it up into a bunch of rectangles or triangles and circles and stuff. But then you just break it apart into discrete pieces and add up the discrete pieces. You don't get to multiply, you just drop it back to addition because that's what you do when the terms are all different. But now we're adults and we're in calculus and things aren't just going to change nice and blocky like this. Things are smoothly flowing from one value to the next, and there's nowhere to put the plus signs. How are we going to make a sum when our terms are continuously filled? That's the weird shit that we have to deal with now. All right, that's it for today. That's it for this week. I'll see y'all on Monday. Everybody have a good weekend, and thanks for playing.